students. Basically, this class will not be like introducing anything new to the table, but it's more of just a recap of what we've already done and how it can be implemented in the most difficult of ways, especially for SPM, where they, especially for matrix, there are many ways that they can play around with the way matrix works that can confuse most students. So with that, I'm gonna start the screen share. So give me a sec. Okay, also forgive me if I slip into BM sometimes, because even though English is my first language, I'm quite used to teaching maths and BM for quite some time already. So yeah, there's that. Jap, eh? Okay, give me a sec. Okay, so we'll be going through variation first. I actually designed it. A lot of these Jamboards were used for teaching in math for the BM classes on Tuesday, but I can of course repurpose them. Okay, so variation. Variation, as you know, is basically when one thing varies let's say varies directly to something. Jab, eh? Yeah, when something varies directly to something. Okay, this is basically things that you've already learned in the past. Let's say we have something like A varies directly, like for example, like what the question will show you. Yeah, varies directly as, for example, the square of x, or in this case, varies directly as b. This is what you've seen before. A varies directly as b, meaning as this means that A will vary, like vary meaning that it will change its value based on how B will vary. For example, let's say B increases, A will also increase. If A increases, B will also increase lah, as an example. So let's try to take a real example for this. And also to write this down in mathematical terms, you usually write it like A varies directly as B, like this. So A varies directly as B. So A varies directly as B will look like this. And essentially what this means is that, like when A increases, if we were to put this in a graph, for example, it means that okay, let's say I put A as the x-axis, for example. When A increases, when A goes to the right, B will also increase. So let's take a real life example. Let's say, for example, speed. Okay, okay, for all of you who have studied speed in your science classes in the past, what is the formula to find speed? Can anyone tell me? Especially for you physics students lah. Type in the chat if you're unable to use your mic at the moment. Distance over time, yes. Thank you, Rachel. So yeah, speed is, as you know, distance over time. Okay, good. So distance over time. Now, what this basically means is that what you can say about there's also another version of variation that you've already studied as well, which is A varies inversely as B. Well, actually no. Let's say we take X varies inversely as Y. Okay, so X varies inversely as Y. You guys have studied this in the past few weeks, and you guys, I presume, have studied this in school already. X varies inversely as Y. Okay, okay, so now I'd like to ask all of you, what would be inside this box over here? X varies to, X is, actually this usually means like directly proportional. Well, yeah, directly proportional, basically. So does anyone know what's supposed to be in this box? like this blue box over here. X fish sign. Well, I guess you can call this alpha. lah. Actually, yeah, it's called alpha. 1 over y. Yes, thank you, Rachel. So yes, x varies inversely as 1 over y. So this means that essentially, this one means the exact opposite of the first one, where when x increases, y will decrease. And when y increases, x will decrease as well. For example, let's say you know full well that let's say we have y is equal to 3. So then x will become like, okay, let's say, actually, no, that's not a proper way to say it. Let's put this in the context of speed. Job, eh? Okay, wait, is everyone following so far? I understand that this might be, might be different to how you were taught in the past. So if you guys are like struggling anyway, feel free to tell me. Okay, wait. So while we're here, do you guys feel like I'm going too slow, too fast, or just okay? If I'm going too fast, then I can slow down a bit. I'm gonna drink some water while waiting for you guys to respond. If there's no comments, then I guess I'll continue going into space now. So, okay. But if I am going too fast, please, for the love of God, just say that I'm going too fast and I will definitely slow down. Because I'd much rather be going at a slower pace rather than make you guys feel lost in this class. Because the objective of this class is to help you guys understand, of course. So, space equal distance over time. Okay, why did I write this down here? Okay, let's say we have s is equal to dt. One can see that. Okay, I can say that. Okay, let me write down something instead. We know that. Let's say we have distance become constant. Let's say this is gonna be hard to explain. Yeah, let's say we have distance is constant. Okay, I'm gonna write this time as time taken, by the way. I mean, you can just write time also in general, but for the sake of this example, the time taken will be important. So as speed increases, okay, let's say we have a race car. As the speed of the race car increases, what happens to the time taken for the race car to, let's say we have a 100-meter racetrack, which is quite short, but yeah, 100-meter racetrack. As the speed increases of the, like, let's say the speed of the race car is higher, what will happen to the time taken for the race car to complete the 100 meters? Can someone tell me? Yes, time taken will decrease or faster. Yes, thank you, Rachel. So time taken will decrease. So since we see that speed is increases, time decreases, we can, well, it's not always a guarantee, but in this case, I can say that speed, well, let's say speed is, let's put speed as v. V varies inversely as t. I'm not gonna put s because for you physics students, especially, that might be confusion. V vary is directly proportional to 1 over t, or v alpha 1 over t. So once you have this, you can make an equation out of it. So v is equal to k over t lah. Now this k is what you call the constant. When you make whenever you convert any variation, like let's say v varies, like v is directly proportional to 1 over t, you must, when you convert the equation, you must multiply this side with any constant, with a letter representing a constant. For example, k or m, basically any letter will work. In this case, I put k, but in this case, you can also put d as if you, let's say you know the formula already. So in this case, d is actually a constant. Yeah, let me show this thing. So v is equal to d over d. So this is, of course, assuming that d is the constant, which is because there's only a 100-meter racetrack. The racetrack is not going to change at all. It's only 100 meters. This you already know. So yeah, basically, what you need to know about anything variation related, when you see these sentences, you write them down in their variation form, like v is directly proportional to 1 over t, and then you convert it to the equation by multiplying by a letter representing a constant, for example, d or m in this m or d. So in this case, d is your constant. Okay, but this is a lot of theory, of course. So let's start going into some practical stuff, because I understand that might be too basic for some people. So practical. Your questions will often look something like this. Given that y varies inversely as the cube of x, and y equals 16 when x is equal to 1 over 2, express y in terms of x. So when you write this down in the alpha form, which I showed just now, okay, can someone tell me how the alpha form should look like? Okay, since you guys can't really type alpha on the keyboard, just type A for alpha. Alpha, by the way, for anyone who's confused, alpha is this symbol. For admats, you'll be using alpha a lot in future. Actually, no. Yeah, you have been using alpha a lot. Okay, so does anyone know how to put this in the form that I showed you guys? The proportional form? Yes, thank you, Rachel. So y is this one is the way you have to write it is y alpha 1 over x cubed. So you have to pay attention to the question. Varies inversely, meaning that's 1 over something, as the cube of x. So the something is the cube of x, which is x cubed. And y is equal to 16 when x equal to half. Express y in terms of x. So in this case, jab. So when in any variation, what must you do to convert it to an equation? So this one is only y alpha. So what if I want to make it y equals? What should I write? Does anyone have an answer? Y equals k over x cubed. Thank you, Rachel. So y is equal to k over x cubed. Okay, so before we move on, I want to talk about about a bit more in detail on why this constant exists. Why how in God's name did this k come to be? Now, if we're gonna put it in graphs, jump. Also forgive me if I'm going too slow. If we're gonna put this in a graph, y x cubed lah. Oh, actually no, y is equal to 1 over x cubed. Because remember, this is y is directly proportional to 1 over x cubed. So it'll look something like this. But just so you guys know, this gradient over here, that's what you call a k. So essentially, in a way, you can see like k is kind of like a y equals to mx. So if you guys have seen like the gradient form before, like y equal mx plus c, but in this case, there's no plus c because variation. Variation, by the way, will always start at 0 no matter what. There is no such thing as plus c. This doesn't happen. So y equals to mx. So in this case, for example, it'll be y is equal to k times 1 over x cubed. And this k is your gradient or your slope in some places. So yeah, that's why k exists in the first place. K is your gradient. So yeah, a variation only tells you that two things will relate to each other, where one increases, another will increase by a certain amount. So if this increases by 1, y will increase by k, because k is the gradient of this relation. So yes, we have y is equal to k over x cubed. Okay, now let's get back to the practical stuff. When y is equal to 6, okay, y is equal to 16 when x equal half. Express y in terms of x. So firstly, you need to do what you need to do. You have to find k. Every time you do this kind of question, you must find k. So okay, I like to ask the floor. How do you find this k? How do you find the constant? Does anyone know? Oh, by the way, don't be afraid if you guys get the answers wrong. It's not like I can punish you or anything. I'm only 1 year older than everyone. So yeah. Substitute the value of x and y. Okay. Yep, that's correct. Thank you, Rachel. Always Rachel. But yes, thank you. So yes, 16 is equal to k over half 0 half cube. So once you have this, you can start writing down everything. You can start writing this down in, okay, we have k is over 1 over 8. You can move this to the left. Then you have 16 times, yeah, 16 times 1 over 8. Do not try to flip this around because this one is already at the bottom. So you don't need to flip it around anymore. So it's equal to k. And now we can see 16 times 1 over 8 equal k. So k is equal to 2. So yeah, once you have k is equal to 2, then you can already express y in terms of x since you already have the k. So your y in terms of x would simply be y is equal to 2 over x cubed. Simple as that. And we're done with this part. Okay, now let's get to the harder parts. It is given that y varies directly at the cube of x and y is equal to 192 when x equal to 4. Calculate the value of x when y is equal to negative 24. Okay, does anyone know how to write this in variation form? Feel free to write it down. If don't forget alpha, you can just type as a because there's no alpha on the keyboard. Yes, thank you, Rachel. So yes, y very directly as a cube of x. You can just write it down as y alpha x cubed. And y is equal to 192 when x equals 4. Calculate the value of x when y is equal to negative 24. Okay, so we move on to this. So when you convert this to this, you'll get kx cubed. Okay, now let's see. Okay, so now I'd like to ask a question to everyone again. Okay, other than Rachel, by the way, this time, since Rachel's already answered so many times. And thank you a lot, by the way, for answering. It really helps. Uh, Nicole or Hazika, what should you do? What's the next step you should do in this question once you already converted to equation form? If you don't know how to do it, then you can just say I don't know or think or anything like that, and I can freely explain. Don't worry if you guys don't know. I just want to, make sure everything's going smoothly. Calculate K, yes, that's correct. Thank you, Nicole. So let's see. To calculate K. Okay, so how do you calculate K exactly? Can someone tell me the answer? How does one calculate K? What's the next step that you have to do to calculate K? Substitute the value of x and y, yes. Thank you, Rachel. So y is equal to 192. Jab. Wait, hold on. Y is equal to 192 when x is equal to 4. Jab, eh? Yeah, 4. So we have k 4 cube. So once you have this, remember you have to cube the 4 first. Don't try cubing the k as well. It's different. 192 is equal to 416. Crap. 16 times 4 is 64, yes. Okay, 64k. So k is equal to 192 over 64. I need to get a calculator because I can't do this math in the blink of an eye. 192 over 64. And you'll get k is equal to 3. Okay, so now you know k is equal to 3. So now you can rewrite this thing as y is equal to 3x cubed. Now, can I ask, will that be the final answer? Is this the final answer? Because just now we had y is equal to 2 over x cubed, and this was the final answer. But for this question, may I ask, will this be the final answer? Nope, nope, nope. Thank you. Oh my God, all of you answered this time. Okay, good. So yes, this will not be the final answer. Be very careful in your exam not to write this. The real final answer is, I think you guys know. Okay, so what's the next step you guys have to take? Yes, we know the final answer will be the value of x when y is equal to negative 24. So what do you guys have to do to find this value of x? Calculate x. Good. And how to calculate x? Substitute y equal negative 24. Yes, thank you, Rachel. So yes, negative 24 is equal to 3x cubed. And this you'll get negative 8 equal to x cubed. And then now your x will simply be the square root of not square root, pull up. The cube root of negative 8. Remember, negatives can have cube roots, but negatives will never have a square root. Unless we are talking about imaginary numbers, which will be something you will learn in college. Actually, I'm not sure how the syllabus changed, but yeah. Negative 8, the cube root of negative 8, you'll know as negative 2, because negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. So yes, your answer will be x equal to negative 2. Is this the final answer? Yep, all right. Thank you, Rachel. Thank you, Azika. So yes, that will be your final answer for that question. And I think, okay, Jab. Okay, now I want to ask the rest of you, since this is just a recap lesson and not a real new topic kind of question. New topic lesson, I mean. I'd like to ask, do you guys want to do another variation question, or do you guys want to move to matrix? Because either way, I also have I do have plenty of questions to practice for. Okay, so anyone? Any opinions? Do you guys want to do variation or matrix? Okay, if everyone's neutral on the topic, then I suppose we'll move on to matrix law, since you guys are already seem somewhat proficient in variation already as it is, based on what you've said. But if you guys want me to help you guys with more variation, then then feel free to like, if you guys are too shy to type in the chat, you can always direct message me here on Zoom. Okay, so matrix. Oh, matrix. Oh boy, matrix. Matrix questions come in many forms compared to variation. Variation usually only asks you this kind of thing, where y very directly as q of x and things like this, where you find the k and then you find whatever when like x when y is equal to something. So generally this is the only way that question come out. They it does change a bit, but the concept generally remains the same. Whereas for matrix, things can get quite complex. Okay, let's hit you guys with an easy question first. We have A, B, 3. I was doing this with the BM students last week, if I'm not mistaken. So let's see if you guys can get it. Okay. B1. Actually, let me arrange this. A, B, 2. Okay, equals to 7, 4, 17, and 8. Okay, the question is find A plus B. Okay, so how exactly would you find this entire thing? I do hope you guys remember how to add matrices. Okay, so what's the first step you would take if you saw this in an exam? Like find A plus B. A is here, by the way. If it's hard to read, let me just change this 9. Yeah, this is 9, by the way. This is 9. This is B, this is A. Let me just color code it for you. Okay, so find A plus B. What would be the first step that you would take as a student? Don't worry if you get the answer wrong. It's not like I punish you or anything. Calculate A and B separately. Yes, thank you, Rachel. So A, okay, as a reminder to everyone, if you're unclear about how addition matrices work, but yes, your matrices, the elements in the same spot, you must add them. They will be added up to find the final thing. So in this case, for example, you can see A plus 5 equals 7 because they're in the same spot in each of the matrices. And the next one we have 2 plus B is equal to 8. So now you can calculate A and B separately. So just remember, just a thing to note, whenever you're calculating addition, make sure you add the elements in the same spots. So in this case, you have A plus B is equal to 7. This actually, no, not A plus B, A plus 5 is equal to 7. So your A is equal to 2. And your next one is 2 plus B is equal to 8. And B is equal to 6. Oh, by the way, if I ask you guys a lot of questions and it's not something that you're used to from the past few weeks, forgive me because like generally that's the way that we usually apply it in BM. It's very like over there it's very like hands-on. A lot of the student it's very like tutors will ask students how they would do it and like it's a way of helping you guys practice lah, basically. But if you guys prefer not to do that, I can like keep it back to like a lecture style where it's just one way. So it's your choice. But if you guys are happy with it, happy with my style as it is, then I'll just continue. So A is equal to 2 and B is equal to 6. So A plus B, as you know, would simply be 2 plus 6 and it'll be equal to 8. And that's basically the end of the question. Okay, any questions so far? Is everyone clear about this? Okay, no questions, no questions. All right, thank you, Nicole. Thank you, Rachel. So let's see. Yeah, okay. We're going to. There is one complex question that I hit the students with that will take some time for you guys to see. So we have okay, we have we're gonna have 3 different unknowns here. They're all constants, by the way. Let me just change this to x. I'll say just same thing lah. Okay, let's see. I hope I'm doing this correctly. Hold on. Hmm. Okay, now this is a more advanced version of the previous question. Okay, the question will ask you to find x plus y. Okay, so I'd like to ask, what is the first thing you should do in this question? Does anyone know? If you're not sure, then you can type no. Okay, form the equation. Which point would you, what equation do you want to form first? Or do you want to just do all 4 of them at once? It's your choice. Yeah, what equation would you want to form first? Or do you want, or if alternatively, you can also do all 4. X plus 8k equal 11. Yes, that's one way to do it. X plus 8k is equal to 11. Okay, but let's see. Yeah, how would you go on after you write this equation? This is a very fundamental step, lah. The x plus 8k. That's a good choice to make. Problem is, unlike the previous question, you have 2 unknowns in this equation, so you can't find x directly. So what should you do to find x per se? What should you do first before which will allow you to find x? Okay, if no one's sure, then I can try it, and then I can try explaining what you should do first. Not sure. Okay. All right. Yeah, the first thing you need to do before you find x is you should look at the other things you can find out first. For example, you can see here, we have 2, and we have 3. We know full well that 2 plus 2 is not equal to 3. But the reason why this becomes this is because we have a k here. So you can write another equation over here, which is 2 plus 2k is equal to 3. And now you can rewrite this to find k. Actually, no, wait. Yeah, you can rewrite this to find k, which is actually what you can do. Since k is only one, in this case, you only see one unknown. as compared to this one, which has two unknowns. So basically, the first step you should take in any matrix question, or generally even any math question at all, is to find a way you can get it to be only one unknown. So yes, 2k is equal to 1, and k is equal to 1 over 2. And now you already have the value of k. So now how can you find x? Can someone tell me? Oh wait, do you guys before we go on to that, okay, don't reply to the question that I asked earlier. Do you guys understand why k is equal to 1 over 2? Or do you want me to explain it a bit more? But okay, actually, no, I can just explain this quickly. K, the reason why it's like that is because k, when you put a k in front of a matrix like this, like an integer, that means that k will multiply all of the numbers inside. So 8 will be times by k, 2 times k, 4 times k, y times k, basically. So yeah. Yep, Nicole, okay, good. All right, so yeah. From there, since you know k is equal to 1 over 2, yeah, since you know k is equal to 1 over 2, what should you do next? What can you do next with knowing that k is equal to 1 over 2? Class? Does anyone know? What shall you do next? Yes, that is correct. Thank you, Rachel. Once you know that k is equal to 1 over 2, you can substitute in directly into here. And now you have a perfect one unknown equation, which is x, x is equal to 1 over 2, 8 is equal to 11. Wait, no, wait, hold on. Sorry, my bad. Yes, x plus 1 over 2, 8 is equal to 11. And then x, I presume you guys can try doing the math. 1 over 2 over 8 is 4. You move it to the right, it equals minus 4. X is equal to 7. Okay, and you can just do the same thing with y. Okay, I won't go too into that because this is a recap. 5 plus ky is equal to 11. K you know as 1 over 2. 1 over 2y, you can move the 5 to the right. You get 6. And then now you can just move it up. Oh, yep, that's correct. 5 plus 1 over 2y equals 6. Thank you, Rachel. So yes. So 5 plus 1 over 2y equals to 11. Wait, hold on. Wait, shoot. Okay, yes, thank you, thank you. Oh my god. I made a mistake. Forgive me. Yes. 5 plus ky is equal to 6. Sorry, class. So yes. Pin. K, you substitute in k is equal to 1 over 2 here. Equals to 6 minus 5. And then y is equal to 1 over 2y is equal to 1. So you can just move this to the right. You'll get, yes, y is equal to 2. That's correct. Thank you, Rachel. So yeah, that's basically how it works. Okay, now I think subtraction you guys know lah. It's basically the same concept. Wait, do you guys want me to go through subtraction or do you guys want to skip? Everyone? Do you guys want me to go through subtraction of matrices or do you guys want to skip to the very important and difficult stuff? Try subtraction. Okay. Subtraction, let's see. Subtraction, I can't really trick you guys anymore because all the tricks are already used here. Let me try seeing what tricks I have on up my sleeve. Determine blah 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 blah. Good. Why is there a good? Yeah, there's not really much I can do. Let me check the previous things that I used for the BM classes. Mathematics matrix identity. Let's see. Yeah, there's all the basic stuff that I've already shown you. Oh, sometimes they also do put 2a, but don't worry too much about it. It's the same concept. Yeah, honestly, it's the same thing. Okay, let's go through. Yeah, you know what? Let's try doing something like that. Good job, man. Hmm. Okay, let's go to something simple. So we have two matrices, and these two matrices will, as you know, subtract each other. We have, let's see, 2a, and we have 3, and we have 4, 7, 8, and we also have, like, let's say 3. Yeah, honestly, I'm just making up these numbers on spot in case that wasn't always ready. Yeah, 3b. Okay, so let's see. Minus equals. Okay, so we have this now. They're asking you to find the value of 2a minus 3b. Oh, I forgot to post the Jamboard in the Google Classroom. I think I'll do that later. But yes, find the value of 2. Wait, no, not 2a minus 3b. Pull up. Find the value of a plus b. Okay, so this one, I think you guys. Okay, so what should you do first, based on what you've already practiced? Find a and b. Yes, thank you. So, thank you, Rachel. Let's see. 2a minus 3 is equal to 7. 8 minus 3b is equal to 5. And you can just do simple algebra. 2a. If you guys want me to stop fast forwarding this part, because this part is, oh shoot, wait. Yeah, if you guys want me to stop fast forwarding this part, I can like make it, I can make it slower if you guys wish. 3b. You can move 3b over here, 5 over here, and then just flip the entire thing. 3b is equal to 3, b is equal to 1. And once you have these two, you can just say a plus b equals to 5 plus 1 is equal to 6. Okay, any question about this? Like any questions at all? Nope, no questions. All right. Thank you, Rachel. Thank you, Nicole. So we'll move on to the next part. Right, just to recap, remember multiplication is like this. When it's an integer multiplied by a matrix, the integer will multiply everything. So like 3 times 1 is equal to 3. I am not using a laser, freak. 3 times 1 is equal to 3. 3 times negative 2 is negative 6. 3 times 3, yeah. You basically understand the how it works. So yeah, that's basically how this all should go. So I think I haven't taught you guys yet. Yeah, there's not. Okay, for addition and subtraction, I think you guys should be fine. Matrix and multiplication of integer with matrix should also be fine. Now, this is where almost everyone struggles for the chapter at this one specific spot, which is multiplication. Because multiplication is pain. Even I can tell you that even during my time last year when I was studying matrices, it took me a long time to figure out how I forgive me, as well, I swear. how multiplication of matrices work. So let's go into that together. So we have, let's see. We have, what kind of question should I put on? Yeah. Let's look for a question. But yes, if you struggle with multiplication matrices, that is completely understandable because everyone struggles with multiplication matrices. Because it's something that no one is familiar with at all when you first see it. Okay, multiplication. Yep, okay. Actually, no, this is by number. Yeah. Matrix by number. Let's see what other questions there are for matrix with matrix. Is there no matrix of by matrix? Okay, I have to make another one myself. Okay, so okay. So let's start with something simple. We have 1, 3, 5, 7, 2, 4, 6, 8. You multiply these two matrices together, you get R. So your task is to find R. This is the most basic possible question you can get. So to find R, you have to multiply these two matrices. Now, how does one do multiplication matrices? For some of you, you might follow the textbook way, which is where you like see where you memorize the positions that how they multiply and stuff like that. But the one I usually teach, and the one that some of you might also be familiar with, is the crisscross method, where you put the left matrix on the left side like this, and you put the right matrix on the upper side like this. And once you do this, you draw two lines. Yeah, I mean, you draw lines based on the rows and columns. For this top one, you draw a line going through the columns. And for this one, you draw a line going through the rows. And once you have this, you check where they intersect. And I've realized okay, you know what? Never mind. We can work with this. Okay, so you can see all the spots where they intersect. 1, 2. You can see there's one over here, one over here, one over here, and one over here. Now, okay. From here, how does one multiply matrix? Basically, you start multiplying like this. You multiply this 1 times this 2. So basically, these two are on the rows that make this intersection point. Okay, this. Please pay as much attention as you can to this part because this is where things can get confusing, especially if you're not familiar with how multiplication works yet. So for this point, we try calculating it. So we have 1 times 2, which is the outer part. So we have 1 times 2. I'll just put bracket 2 here for now. And we have another one, 3 times 6, which is the inner part. So basically how this works is that on this dot, you can see that it has 2 and it also has 1. And these are the furthest away. It's like a triangle in a way. So 1 times 2, and then you plus it with the other pairing, which is 3 times 6. And then you basically do this for all the points. For example, you do the same thing with 4, 8. Jam. I might need to zoom in a bit. Yeah. Okay, let's do it with all of them slowly. 5 for this dot down here, you can write 5. You see that 5 will be paired up with 2 this time. So you have 5 times 2 plus 7 times 6. And so on and so forth. Basically, I think you guys might understand. Okay, just to test, how do you find this part? Can someone tell me the equation for this part? For example, this one has 5 times 2 plus 7 times 6. This one has 1 times 2 plus 3 times 6. How do you find the red dot over here? Does anyone know the answer? One times 4 plus 3 times 8. Yes, thank you, Rachel. Thank you, Nicole, as well. Okay, thanks both of you. Yeah, that's actually correct. 1 times 4, job. Sometimes we're using micro Jamboard is pain. 1 times 4 plus 3 times 8. Yeah, honestly, in real exam, I suggest you guys don't try drawing the arrows because it gets really messy real fast. So, but this is just for the sake of demonstration. And for the last one, you can see already that the same pattern. It's 5 times 4 plus 7 times 8. Okay, so now all you need to do is just calculate all these, which will take a very long time. 3 times 6, 18 plus 20. We can see, you can calculate all these additions, 20. This one will be 35, 42, 52. This one 52. This one will be 8, 16, 24, 28. And this one will be job 56, 76. So once you have all these values, you put them all into the resulting matrix. So basically all these dots here are actually the location of these elements. So in this case, you have 20 at the top left. We have 52 at the bottom left. We have 28 up here. And we have 76 down here. And that's basically the end of your question. So this is basically what R is. So you can just write R is equal to 20, 52, 28, 76. Of course, in a real exam, if you're doing this working, you must certainly show this entire thing. You have to show the main marking point that they'll give you. You have to show the addition over here in particular. This addition is very important. If you just skip from here to here, and you don't show any working in between, then you won't get as many marks. So make sure you put the plus these together. And if you don't like using crisscross method, make sure you show the plus together as well in your working later on, because this is the most important part, the plussing together like this. Okay, so any questions about multiplication matrices so far? Oh, it's 9:36 p.m. already. Okay, no. Okay, nope, nope. All right, then we shall proceed. Okay, let's talk about identity matrices real quick. So, okay. I'm gonna skim through this because this is not too important, but also still important. So you know full well that whenever you times x by 1, you always get x. So if you times 3 times 1 is equal to 3, 4 times 1 is equal to 4, so on and so forth. Now in maths, they tend to call these numbers, whenever you multiply with these numbers and you get the same thing, this is what you call an identity number. Now, why is this important for matrices? Okay, this is just additional info. Identity numbers are, when you multiply by identity number, it will give you the exact same thing. So essentially, matrices will have a very similar thing, which is, let's say we have a thing called as an inverse matrix. Wait, no, inverse pula. Identity matrix. Identity matrix is whenever any matrix, like let's say we have matrix A, for example, in this case, matrix A. Whenever you have matrix A and you times it by the identity matrix I, let's say, okay, yeah, let's call identity matrix I. A times I, you'll get A. So essentially, any matrix multiplied by this I will get the same thing. So like matrix B will equals to B by B. Sorry. So A times I is equal to A, B times I is equal to B. So this inverse matrix will vary based on the size of the matrix itself. So let's say for 2 times 2, the main identity matrix you need to know is 1, 0, 0, 1. And to prove that it works, to prove how it works, I'm gonna show an example. Okay, 3, 4, 5, 2. Let's start with this. 3, 4, 5, 2. And let's say we want to multiply it with the identity matrix. I said I would skim this, but I'm taking quite a amount of time. 3452 times 1001. Okay, so of course, you multiply these two. This is what you call, this is AI. AI is equal to 34521001. So when you put these side by side, you do the crisscross method as usual, like with any other multiplication. 34521001, and you can see you do the crisscross thingy. Crisscross buns are great, by the way. But yes, back to topic. 3 times 1. 3 times 1 plus 4 times 0. You can see, you can make the pairings. Okay, can someone, okay, just to check up on everyone. How do you find the red dot here? Oh, the same spot as before. Yeah, how do you find the red dot here? Can someone give me the equation? This red dot, by the way. Ignore my cursor. Well, my cursor is on the red dot now anyway. Actually, it's not. Yeah, how do you get that red dot over there? 3 times 0 plus 4 times 1. Yes, that's correct. 3 times 0 plus 4 times 1. Yes, thank you, Rachel. Thank you, Azika. So, yes, I'm glad you all are paying attention. Yeah, 3 times 0 plus 4 times 1. And yeah, 5 times black. And then you can just do this entire thing for all of them. 5 times 1 plus. I think you guys can see what I'm trying to show. So at the end of all this, you'll see very clearly that, okay, job 5 0 2 1. Okay, you can see very clearly that the resulting matrix, once you count everything and all said and done, is actually just 3 4 5 and 2 again. So yeah, it shows the exact same thing, the exact same result. 3 4 5 2. And that's how we can call this identity matrix. Because whenever you multiply any matrix of a 2 times 2 size with this, you will get the exact same matrix back. Like so. So yeah, that's basically how identity matrix works. Now that brings me to the topic of inverse matrix, which can also confuse people quite a bit sometimes. Now, you know full well that, okay, job. X times 1 is equal to 1. Wait, no. X times 1 is equal to X, sorry. X times 1 is equal to X. But how do you get, okay, we're gonna make this a subject. You will also see that X divided by X is equal to 1. So you bring this in here, for example, X over X equal to 1. Or you can also say this as X times X to the power of negative 1 is equal to 1. Now, what exactly am I getting at? Okay, so we'll get to that in a second. So whenever you have a matrix, in most cases, not all cases, by the way, some matrix do not have an inverse matrix. I will demonstrate an example of a matrix that does not have an inverse matrix later. But yes, inverse matrix. An inverse matrix is basically yeah, I actually don't know how to describe it, except for the fact that it's an inverse of the original matrix. For example, the inverse of A would be inverse of A. Wow, this is big. I wonder why. Inverse is A is equal to A to the power of negative 1. So yeah, A to the power of negative 1 is the inverse of matrix A. So as you know already, A to A I will equal to A again. So and matrix A times identity matrix will equal to A again. But if you want to, let's reverse this entire thing. A over A is equal to I. If we move the A over here. Now, you can also write this as follows. A to the power of negative 1. A times A to the power of negative 1 is equal to I. You can see similarities. This is actually the exact same concept. So basically, inverse matrix is A is the inverse of the original matrix, like so. So whenever you multiply an original matrix by its inverse matrix, you will get an identity matrix back. Basically, that's how it works. So yeah, that's basically how it works. You take your original matrix, you multiply it with an inverse matrix, and you'll get your identity matrix, which is 1, 0, 0, 1 in this case. Okay, so how the frick do you get an identity matrix? Honestly, just follow for this one, you have no choice but to follow the formula. A to the power negative 1 is equal to, okay, let's say we have A is equal to 1, 2, 3, 4. I'm putting real numbers because when you put letters, it can get confusing. Okay, yeah. A to the power negative 1 would be equal to 1 over 1 over AD. Yeah, okay, you know what? I'll just put letters actually. Or no. Yeah, actually, you know what? Okay, chap. Yeah, 1 times 4 minus 2 times 3. Okay, so that's your coefficient. And then once you get that, you go in your matrix. Now for inverse matrix, these two, the blue ones, the top left and bottom right, this is for 2 times 2 only, by the way. Don't try applying this to 3 times 3. 3 times 3, inverses are much more complex. And even I don't know how to do them actually. So for now, just do what you've been taught to do. 1 and 4, the top left and bottom right, you just switch their positions. 4, 1, switch. Whereas for the top right and bottom left, okay, can someone tell me what you do to the top right and bottom left? Does anyone know the answer? Yes, -2 and -3. What you do here with the top right and bottom, yeah, top right and bottom left, is you just you multiply it by -1. For example, if this is 2, it becomes -2. This is 3, it becomes -3. Or if let's say it was originally -2, then you would change it to be +2 instead. I'll write it like that. So yeah, this is how you find the inverse matrix. I'm not gonna prove that this will give you identity matrix when you multiply with original. You can try doing that on your own, but I could do that right now. Actually, no, I won't. There's much more important things to get to. But yes, when you multiply this matrix, like this entire thing, don't forget the coefficient. The coefficient is important. When you multiply this entire thing, with the original matrix, you will get I back. With the original matrix, you will get 1, 0, 0, 1, or which is also I. So yeah, that's basically what inverse matrix is. Okay. So, any questions so far regarding inverse matrix? Nope. All right. Now, let's see if I have a... Okay. Let's start with a trick question. This question, they will sometimes ask, they will very rarely, but not never, because it has happened before. They will ask this kind of question. Matrix A is equal to, like, let's say this is just a placeholder, 5, 2, 3, A. No, actually, no, that's a bad number. Is that right? Okay. Matrix A is equal to this. it is given that matrix A has no inverse matrix. Or in other words, it's, yeah, has no inverse matrix. Actually, no real inverse matrix. Now find the value. Actually, I'll change this to X. Yeah, find the value of X. Now this one, I actually struggled to do the first time I saw it because it's something that you'll have to think for a while. Find X. Okay, does anyone at all? Just to see if anyone knows how to do this. Does anyone know how to find X at all? Because this one is like K-Bot already at this point. Anyone? No idea. Yeah, okay. Actually, the same thing for me. I had to check the answers to find the real way to do it last year when I was studying for SPM. Yeah, so last year I was studying. I was going through matrix to study for SPM, and I found this question, which is quite honestly, I just tried to do it for some time and I got stuck. So this is how you find it. So let's say, when it has no real inverse matrix. Now, let me ask you something. When does, okay, 1 over x, at what value of x does 1 over x become not real? Does anyone know the answer to this question? Okay, yeah. Okay, if no one has any idea, it's actually 0 when x is equal to 0. Because, as you know, nothing can divide by 0. If you try dividing by 0, you actually get, it's undefined. If you try doing the calculator, if you try now, you'll get math error. It's undefined. So anything divided by 0 is undefined. Now, if you remember correctly, just now we had okay, let's try finding the inverse matrix of A. 1 over 8x plus 4, 6. Wait, no, not plus. Remember, this minus. Minus 4, 6. 8x, negative 4, negative 6. Now, how do you make this not real? Can someone tell me how do you make this not real? How does one make this thing not real? I gave you some related info earlier, so use that wisely. Yeah, x, okay. Yeah, we know this. Where at this part, yes, when x equals 0, 1 over 0 become undefined. But of course, in this case, you can't put x equals 0 because x 8, 0 minus 4, 6, you'll still get a value, which is negative 1 over 8 minus 24. You'll get negative equals 16. So no, you don't put x equals 0 for this one. But if you're answering this question, yes, you're correct. So, okay, how do you make 8 to the power negative 1 not real? Can anyone tell me? I'll give it 10 seconds. Okay, so 10 seconds have passed. Basically, how to make this not real? You have to make it so that there'll be a divide by 0. Because when you divide by 0, when you divide anything by 0, it will not become real. Because divide by 0 is not real. It just doesn't exist because you can't divide by 0. There is actually a very long explanation as to why divide by 0 doesn't exist, but I won't go through that today. But essentially, the main point here is that you have to make this denominator 0, which means that your real equation that you should be doing is 8x minus 4/6 is equal to 0. Because remember, there's no real inverse matrix, which means that this will become divided by 0, which means that there is no real inverse matrix in the end. So a to the power -1 will not exist because it's 1 over 0. So now the answer is just this. 8x is equal to 24, and you'll get x is equal to 3. Okay. Okay, that was the experience. So just to make sure none of us are lost, is everyone clear about this? And then after this, we'll go to the more traditional question, which is simultaneous equations. Okay, so is everyone clear? Any questions? No questions. Okay. Anyone else? Nope. Okay. All right. So yes, just remember anything divided by 0 is undefined. So in this case, since there's no real inverse matrix, you have to make this equal to 0 so that it doesn't happen. So essentially, this means that in this case, like I said earlier, not all matrices will have an inverse matrix. This is one of the examples, matrix A, which is 3, 4, 6, 8. Okay, now let's go to the main stuff. Simultaneous equations. So let's begin with a simple simultaneous equation. I won't do like all those big word questions today. Okay, job. But I will like show some complications that might mix things up a bit. Job. I need to make sure that my equations are correct because this, if it's not, then it's gonna be pain. Oh, we might be going a bit late. So if you guys need to go early, like at 10 p.m. later, feel free to do so. I will be starting this class until like 10:05 or 10:10. So yes. So just a bit longer. Yeah, there's literally no sample questions here. Jump. Simultaneous equations matrix SPM. Or I can literally just go to the BM. Jump, eh? Hold on. Oop. Oh, okay, never mind. Yeah, I didn't teach this before. Yes. There in your SPM, they are usually asked things like this. Write the following simultaneous linear equations as matrix equation. Hence, using matrix method, calculate the value of U and V. Okay, job, eh? 3U equal 9 plus V. And next you'll have 5U minus 2V equal 13. You may have noticed I changed something. Okay, so you have this, right? The simultaneous equations in the form of matrices. Hence, using matrix method. Only do this when they say specifically using matrix method, or matrix method is actually, yeah. Hence, using matrix method, find U and V. By the way, for some questions, they won't allow you to use matrix method. Like they'll specifically tell you do not use matrix method. So make sure you read the instructions very carefully. Okay. Now, I like to ask, what's the first thing you should do in this entire thing? Before you start with anything, what's the first thing you should do? Yes, thank you. That is correct, Rachel. Make sure you rearrange it properly in such a way that all the unknowns are on the left side. So you'll get, this one will become 3u minus v is equal to 9. And that will be your new equation. Okay, now that we have this, we're all set. So you start with writing a matrix for this. So your 3, we have 3u, we have negative 1v, we have 5u, and we have negative 2v. And then you multiply this with uv, and then you'll equal this with 9, 13. Okay, if you guys want to know how this works, actually no, I won't go into detail, but basically remember crisscross method, it'll be like this, blah, 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 blah. 3 times u will become 3u minus, and then negative 1 times v will become negative v. And it'll become like this. So that's essentially the rough concept of how it works. But you don't need to know that, of course. It's just if you want to understand why we put it like so. Because essentially this is just a way we rewrite the entire thing. So this is 3u, so you'll get like something like 3. If you try multiplying these straight away, it'll be 3u minus v, 5u minus 2v is equal to 9, 13. Which is actually your simultaneous equation. So you literally didn't, basically, you just went back to the start. You will multiply directly. So instead of going back to the start, like I just did, you have to, okay, what do you do from here? Actually, since you guys studied this already, what should you do once you already write the matrices like so? Does anyone know the answer? If no one knows the answer, then okay. One more thing, right? I'm gonna explain why, one more thing as to why I was talking about inverse matrix so long earlier. It's because in matrix, there's no such thing as divide. Because, okay, let's say we take this. Let's say this is A. This is matrix A. And we move it here. There's no such thing as divide matrix. That doesn't exist. Dividing by a matrix does not exist. So essentially the matrix version of divide is actually inverse matrix. So you move this here. You move this here, you'll get 1 over A. Whoops. Ignore that. But yes, this A, because this one A will be multiplying UV, you move it to the right, you'll get 1 over A instead. So you like divide. So yeah, that's how it works. And that's your inverse matrix. Okay, so I think I literally just told you the answer to what I asked just now. Oh, by the way, inverse matrix can be represented as either 1 over A or A to the power negative 1. It's actually the same thing. Don't worry about it. Okay, so now that you do this, you have to find the inverse matrix of A. So now we have UV is equal to your inverse matrix, which will be 1 over 3 negative 2. Okay, wait, is everyone following so far for this? Like, is everyone clear about like why I'm moving the A here and making inverse matrix? Yes, okay. Everyone else? Oh, it's 10:04. Oh crap, we need to rush this. All right, thank you, Azika. Thank you, Rachel. Yes. 3 negative 2 minus negative 1, 5. Multiply this by 9, actually, no, not 9, 13 pula. You, okay, so, okay, I know I'm slowly rushing this, but I'll still ask you guys a question anyway. What do you do with the green stuff, with the green numbers, the ones that are highlighted in green? Just to refresh your memory a little. Switch position, yes. Thank you, Rachel. Negative 2 and 3. And as for the other one, highlighted in blue, what do you do with this one? Add negative, yes. Well, not really add negative, but more like multiply negative 1. So in this case, actually, no. Yeah, you're basically correct. Because you know that negative will become a positive. So yes. Thank you. Let's see, who is that? Thank you, Nicole. So yes, you have negative 1 times negative, you get 1, and this will become negative 5. And that's basically how you find the inverse. Now, is this the final answer? Actually, whenever I say that, it's a dead giveaway that's not the final. Okay, but is this the final answer? No. Okay. All right. So, how do you find the final answer? Oh, right. Okay. One. Okay, this is actually an important point. Do you multiply the fraction with the matrix first, or do you multiply the matrices with each other first? This is very important. Which one do you do first? Do you multiply red, or do you multiply yellow? Matrix and matrix. Yes, that's correct. Thank you, Rachel. So yes, make sure you do your matrix first. Job. I'm running out of space. I'm gonna duplicate this slide. I think I'll post it in Google Classroom later. Jump. Okay. Oh crap. Ay caramba. Okay. So yes, you do your matrix first. You multiply your matrix with your matrix first, and you get something like this. You crisscross 9, 13. By the way, even if the matrices are different size, you can still do the same thing. There is certain cases where you cannot multiply two matrices, but generally they won't test you on that. They usually just give you matrices that can multiply with each other. So now we have 9 multiply negative 2 minus 1, 13. And you wait. Yeah. Okay, so now to jog everyone's memory a bit, how do you find the red dot? The red coordinate, well, dot over here, yes. Actually, it's getting quite late, so I think I'll refrain from using too much of your time. Yes, let's see. Yep, that's correct. Thank you, Rachel. So yes, wait, hold on. There is one, don't, that 9 is not, just a note. The 9 over there is not necessary, but yes, Aranda is correct. 9 negative 5 minus 3, 13. And yes, after this, you'll find the answer, which is jump. Negative 18 minus 13, you'll get negative 31. Wait, is this really the answer? Ah, well, whatever. Negative 5 minus 3, 13. You'll get negative 84. feels very strange, but oh well. And now once you're here, this means that UV is equal to 1 over, you can just calculate this on your own, which will be -6 minus -5, which is plus. You get -1 over, wait, what? -6. Yeah, okay, actually, no, that's correct. So you just get -1 because it's just -1 over 1. You'll get -1, -31, and -84. And your final answer will be UV is equal to 31 and 84. And your U will equal to 31. V will equal to 84. And that's basically your final answer. All right, so any questions regarding this entire thing? Okay, wait, I might have rushed the last part, but I hope you guys understand it. Basically, once you have the result for this, you take these two. Once you multiply these two, you'll get this. And then once you have this, you multiply it with the coefficient over here. And you'll get the answer. UV is equal to 31 and 84. Inverse matrix -5 minus 6. Is that my mistake? Yeah. Hold on. Wait, Rachel, can you tell me which part precisely did I make mistake? Inverse matrix. Oh, shoot. Okay, thank you. I think I get what you might be catching on. Shoot. Right. Okay. No, never mind. I think I might be delusional. No, wait, no. Yeah, okay, no, never mind. Yeah, Rachel, can you clarify? Because I might have made a mistake somewhere. But let's see. Let me check. U is equal to 5, 6. Wait, then okay, I definitely made a mistake somewhere. Oh, okay, thank you. That's very important. Sorry, class. I made a mistake. Yes. This one is plus. Yeah, for multiplication, make sure you know it's plus. Sorry. This one is very important. These two you plus together. 9 -5 plus 3 13 is equal to jab, eh? Hey, this A plus math student making the simplest of mistakes. Okay, -18 plus 13, you get -5. -45 plus, wait. Yeah, okay, no, never mind, it's correct. 9 -5 plus 3 13 -6. Yep, and that's the answer. That's the real answer this time. Thank you for bringing that up, actually, Rachel. That's very important. So you have UV is equal to 5, 6 because you already times it by -1. And now you just have U is equal to 5, U is 6. And that's basically it. Okay, any questions at all about this question in general? About simultaneous equations in particular? This is the most common question that you'll find in exam. Like it's what they will almost always give you this kind of question. Even for my year, they didn't give me, but yes, usually they'll give you this question. So you have to remember how it works. Okay, any questions at all? Nope. Okay, let's see, who else? Hazika, any questions? Nope. All right. Then with that, I think we can wrap up this class. Sorry for taking up 13 additional minutes of your time. But yes, other than that, thank you guys so much for coming to the class today. I also especially thank you to all of you for answering my question, the question that I put to the floor, especially Rachel for like answering the most often. And yeah, with that, thank you for coming to today's class, and I hope my teachings today will benefit you in the future. So with that, thank you. Bye bye. Thank you. Bye bye. Bye Rachel. Bye Hazika.